The nth root test is very similar to the ratio test and can often be used interchangeably with the ratio test. And this says that if the sum from 1 to infinity of an is a series, and if you look at the limit as n goes to infinity of the nth root of the absolute value of the nth term, if that's less than 1, then the series converges absolutely. If it's greater than 1, the series diverges, and if it's equal to 1, then the test is inconclusive. And this is especially useful when the expression for an is some expression in n raised to the power of n. So let's use this test to figure out if the sum of minus 1 to the n minus 1 times 2n over n plus 1 all raised to the power of n converges or diverges. Well, we take the limit as n goes to infinity of the nth root of the absolute value of an. So this is the limit as n goes to infinity of the nth root of 2n over n plus 1 to the power of n. And of course that power of n disappears, it gets cancelled out by the nth root. So we're looking at the limit as n goes to infinity of 2n over n plus 1. And this of course equals 2, which is larger than 1, and by the nth root test we can conclude that this series diverges. Let's try another example, this time the sum from 1 to infinity of n over 2n plus 1 to the power of n. Well, let's apply our nth root test, and we take the limit as n goes to infinity of the nth root of the absolute value of the nth term, which is the limit as n goes to infinity of the nth root of n over 2n plus 1 to the power of n. So this is the limit as n goes to infinity of n over 2n plus 1, and dividing by n above and below, we get that that's equal to 1/2. And of course 1/2 is less than 1, so we can conclude that this series converges by our nth root test. Let's try one last example. The sum from 1 to infinity of the natural log of n over n to the power of n. This is obviously an ideal candidate for the nth root test, so that we don't have to worry about that nth power. So the limit as n goes to infinity of the nth root of the absolute value of the nth term is the limit as n goes to infinity of the natural log of n over n. And now this is an indeterminate form of type infinity over infinity, so I can use L'Hopital's rule here. Replacing the n by an x, I take the derivative of the numerator and denominator, and this is equal to the limit as x goes to infinity of 1 over x over 1. And of course, as x goes to infinity, 1 over x goes to 0, so this whole thing goes to 0, which is less than 1. So my conclusion is that this series converges because of the nth root test.